which are electrical fluctuations that can be measured at the surface of the scalp, which result from neurons firing. We have dreamed and imagined of a time when it might be possible for us to control and influence our environment simply with our brain. And this has been the subject of science fiction novels, movies, games, and the list goes on. This was an area that captivated the imagination of our team at Emotiv. We were inspired by the idea of being able to introduce total communication to computing platforms, applications, and devices. Because up until now, our communication with machines has always been limited to conscious and explicit forms, whether it's something we do every day like turning on the lights with a switch, or more complex things like programming. We have always had to give a command, or even a series of commands to a machine in order for it to do something for us. Communication between people, on the other hand, is a lot more interesting and far more complex because we take into account so much more than what is explicitly expressed. We observe facial expressions, body language, and we can intuit feelings and emotions from our dialogue with one another. And this forms a large part of our decision-making process. So our vision is to introduce this whole new realm of human interaction into human-computer interaction, so that computers can understand not only what you direct it to do, but it can also observe and respond to your facial expressions and emotional experiences. And what better way to do this than by interpreting the signals naturally produced by our brain, our Center for Control and Experience. Well, this sounds like a pretty straightforward idea, but the task wasn't easy for two main reasons. The first reason is the detection algorithms. Our brain is estimated to be made up of up to 100 billion neurons, representing around 170,000 kilometers of combined axon lengths. When these neurons interact, the chemical reaction emits an electrical impulse that can be measured. The majority of our functional brain is distributed over the outer surface layer of the brain, and to increase the area available for mental capacity, the brain's surface is highly folded. And this cortical folding presents a significant challenge for interpreting any surface electrical signals. So each individual's cortex is actually folded very differently, much like a fingerprint. Even though a signal may come from the same functional part of the brain, by the time the structure has been folded, its physical location is very different between individuals, even identical twins. So there's no longer any consistency in the surface signals. Our breakthrough was to create an algorithm that unfolds the cortex so that we can map the signals closer to its source, and therefore making it capable of working across a mass population of users. The second challenge that we faced is in the device for collecting brain waves itself. So EEG measurements typically involve a hairnet with an array of sensors like the one that you see in this photo. A technician will place the electrodes onto the scalp using a conductive gel or paste, and usually after a process of preparing the scalp by light abrasion. So as you can imagine, it can be a time-consuming process and isn't the most comfortable. And on top of that, these systems cost in the tens of thousands of dollars. So with that, please allow me to invite on stage Steve Herod, who has so kindly agreed to help me to demonstrate what we've been able to develop. Hi, Steve. How are you feeling this morning?
My brain is working better than I thought it might after the party.
That's a good sign. So what you see here is a 14-channel high-fidelity EEG acquisition system. It doesn't require any scalp preparation, no conductive gel or paste. The headset's also wireless, giving Steve the freedom to move around. And compared to the tens of thousands of dollars for the headset that you saw before, this device is only a few $100s.
Fashionable as well.
Yes, very fashionable. So what you see on the screen here is Steve's brainwaves. You're taking a live stream of his brainwaves. Looks pretty calm and relaxed. Okay, so now that we've done that, I mentioned facial facial expressions and emotional experiences. Those are designed to work out of the box with some sensitivity adjustments available for personalization. But with the limited time that we've got, I'd like to just focus on the cognitive detections, which is the ability for Steve to move an object just with his mind. So Steve is a new user to the system, so what we need to do with any new user is to add a new profile for him. So I'll just add Steve here. Okay. So the process for training up a new user to the system is fairly straightforward. We start by observing a neutral or baseline state. And with this, there's nothing in particular that Steve needs to do. He's just hanging out, being comfortable, fairly relaxed, as we saw with his brainwaves before. That goes for 8 seconds. And now that that's done, we can start choosing an action. So, Steve, what you want to do is choose an action that you can imagine quite well in your mind.
Okay, let's do a lift.
Okay. So the way that training happens is you want to imagine the cube slowly rising into the air. The first time nothing will happen because it has no idea how you think about lift. There's a progress bar that will scroll across for 8 seconds, and you want to maintain that mental thought the entire time.
Okay.
So ready? 1, 2, 3. Okay, so now that it's had one example of Steve's brain, the system is live, and he can try.
Let's try another one.
Okay. Okay.
This must be what Yoda feels like.
Maybe you can try disappear. Disappear is more difficult because it's not movement-based action, so there's no analogies for that in our physical world. So it's the same idea, but here you want to really imagine the cube slowly fading out into the black background. So let's start. 1, 2, 3, go. Okay. It's live, and you can try it.
We're trying real hard.
A few drinks doesn't really affect it too much.
Very neat.
Well, as you can see, it only takes a few seconds for you to train up a brand new user to the system, and there's an algorithm, a learning algorithm built into the system so that it gets better with time. So the more it understands Steve as a user, it will get better in terms of responding to you.
Very neat. Thanks
very
very much.
Thanks, Steve.